Daz, and another radio kit. This one's a little bit different. This one's got a display in it, so it's a clock radio with FM band, so that should be a little bit of fun. Well, it looks like one of my inductors has got a bit flattened, but I'm sure we can fix that with a drill bit. I noticed there's some little metal bits, because I was just wondering how the contacts worked on that. So they're obviously little bits that spring down. No surface mount in this kit. So basically you've got an AM FM IC and an audio output IC. Audio IC is a TDA 2822, which looks like a an H-bridge type driver, so that'll have a higher output. And this is the CD 2003, which is AM FM, but this is only used for FM. There's a couple of transistors. I think one's used as an RF preamp, yes, and the other one's used to switch the radio on and off from the alarm clock module. There's push button switch, some wires, so ceramic filters, so no cores to set up, so this is a relatively easy to set up radio, I guess. So yeah, very interesting. Reasonable size speaker. Receiver with alarm clock, 74 to 108 again. Now I noticed the display has got a frequency input, so I assume that will display the frequency of the radio, so that might make alignment easier. So that's good. Right, this is not ideal static wise, but it's the PCB. So basically you're tuning the radio and the display is monitoring the local oscillator to give you a readout. So yeah, it doesn't look too bad to build. Instructions have got some English in them, so I can always use Google Translate. Okay, let's get on with it. Well, things to note. I noticed some of the larger capacitors are all over the place, so the 100 enough are more, 100 nanofarad are more like 47s, the 47 nanofarads are a bit all over the place as well, but they're just decoupling capacitors, it doesn't matter. What else? ICs are clearly marked, so no problems there. Capacitors seem to be marked to be bent down. The switch doesn't seem to matter which way round it goes. Yeah, so not too difficult really. I've just got to sort out how many turns are on each of these coils and place them in as appropriate. Let's see, are the turns stated? I think they are. I say that without even looking at the instruction. Yeah, 5.5 turn, and there's two 6.5 turns, so that shouldn't be too hard to get. The other puzzlement will be checking this capacitor, I guess, to make sure it goes in the right way, because I wonder if this looks like a medium wave FM one again, so I don't want to put the high value in. So what else is there to note? Some components left over for some odd reason. Ceramic resonators. There seems to be a mark on here again, and I've put the red end to it. I never have fathomed out whether there's a reason for that, but let's get a close-up of the board. I think it would be a good idea. Let's see if we can just get in a bit closer without going outside the range of the camera. So there's a close-up. There we go. So yeah, there's the red marks on the ceramic filter and resonator. I guess the resonator's used for the demodulation of the 10.7, and that's just a filter, just a single one, but it's probably quite adequate. Notice the 2 centre pins are used on this. So if you've got headphones in, you're going to get anti-phase, I guess. I don't know what that's for. I've no idea. So it's just the inductors for the front end and local oscillator and the tuning capacitor to get in. So right, that's the next task. Right, let's see what we've got here. Now, put the circuit board away, I didn't really want to. So those are the 2 capacitors that are being used. So I'll want to find the sides of this that are the lower capacitance. Right, let's zoom out a bit again. Right, I'm trying to do this more as less as one shot, so I'm getting lazy in my old age. I'm getting fed up of so much editing. What we got? 35 puff. Let's put it all the way that way. 14 puff. And let's put the capacitor back all the other way. See what we've got. 34 puff. That does sound more like a VHF type reading. Let's try it this way. What do I get this way? 161. Okay. Let me go back over this side. 36 and 104. Oh, that's intriguing. Right, okay. So I reckon that's the medium wave gang. So it's going to be the VHF gang on this side, I guess. 39 puff. So that will be that way round. Right. There we go. I want to get the capacitor right way around. I don't want to use the medium wave side, do I? Interesting, these don't appear to be solderable, so I guess you just put them on the board and screw it to the front, and they're held in position presumably by the switches, hopefully, but I'm not sure how else to hold them in. I've seen Captain tape used to hold them in, but not quite sure on this. Right, okay, I've gone for a bit of tape. Can't find the Captain tape. I might have used it all, and I've just guessed that you melt the points here so that this doesn't fall out. Good. Couldn't really get the colour code to match, but I've gone for red for VCC. Guess that'll go in there. Picked up the tape being in the way of the holes now, but I'm sure we can soon cut that out of the way. Looking promising. I can see we obviously need a bit of alignment. We're down to 68 and I can only get up to 95, so probably the trimmer capacitors need adjusting. Right, so this is the local oscillator, so I've tuned it right to the end. Let's just get up to 108. Yep, there we go. So what does it go down at the low end? Ooh, a bit less than 74, but I suppose I could have a go at the coils. But what I want to do is set up this trimmer, the aerial trimmer, at 108 for maximum sensitivity. But I think I'll see if I can get the local oscillator a bit more different first. As you can see, I've just bent the inductor out a little bit. It does the 74 range. Ideally, I don't really need that. I could do it at up to 188 if I was to make the core smaller. You can see it changes as I put my finger. Not as much as you thought it would do, but I guess the other one needs doing with a signal so that I can peak the sensitivity at the low end of the band. And yeah, of course I've now got to tweak the trimmer again, because altering the inductor has altered the top range of the radio, so I should have really started here and then adjusted this. Just going to have a go at the aerial trimmer, about 107 megs. Well, I must admit I've had a little twig with the two inductors on the aerial circuit, and I can't really see much improvement. It's already really quite sensitive, and I'm picking up the national stations, which is 40 miles away, on this bit of wire, and yeah, it's quite sensitive. It may influence the rejection, but it does seem a very sensitive little radio. So really, I guess it's down to the local oscillator coil and the aerial and oscillator trimmers. That seems to have got me pretty much in the ballpark. So yeah, I was thinking about changing these inductors to start at 88 instead of 74, but nah, I think it works fine as it is, and I think this is quite a big tuning knob, and I think that'll be fine. Sometimes I think you can just end up doing too much. Forgot to put that on. Make sure the cables don't catch the tuning dial. I'm going to put it together now, I think. Had to think of where the terminals went. I think that's the right way around, with the negative on the right. It seems to go together better that way, so I'll go for that. Always read the instructions. I did do a Google Translate at last, this late in the situation, and you actually remove this power switch, so this button goes right through. I also note it said to use adhesive tape on here, so I should have read that in the first place. What an idiot. Never mind. Just the way it goes. Good. There we go. Right, now this latching on off switch can go through. I'll put it back together now. Assume these are the right polarity. So screw it back together now. As far as I'm concerned, the alignment is fairly good, so just proceed to put it back together. More mistakes on my part. These screws do not need to be fitted because they're done for the battery compartment. They go through the battery compartment first. Just got to try and keep this aerial lead short. Woof 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 to you as well. Yeah. Okay. Just checking the standby current of the clock, and it's very low. It's about 50 microamps, so I'm not worried. What is the time now? 7:35 in the evening. There we go. Nice contrast on the display. Well, at the lower angle, but I suppose if you're in bed it would be. So yeah, that's good. So let's just have a quick band scan. Yeah, good. So it's picking up all the stations I'd expect. Obviously this lower part is of no use to me in the UK, but yep, that's going well so far. So alarm display. Right, let's just set that up then. So 40. Quite time consuming. It doesn't go that fast, but hey, at least it's got auto increment. It'd be quicker doing it this way. Right. Alarm on. Okay, let's see what happens.
Like we said, it's contained and clear and boiled down to an essence that is, you know, beautiful.
Good, that's working fine. Bit of YouTube music. Well, I'm quite pleased with this kit. It's not a bad kit at all. The 2822 bridge driving chip gives a nice output power. So it's got quite a loud sound to it, which is quite good. No surface mount components. Alignment's easy because you've got the frequency meter built in. I like that as well. So yeah, that's not a bad kit. I'm quite pleased with that. No component shortages, more some left over, but that's never a problem. Rather a few components left over than not enough. So yeah, I quite like this kit. Not bad at all. So yeah, glad I bought this one.